I should have asked what platform you're going to put this on. I failed to do that. I assume Copter, and I'm going to give you for Copter right now. But most of this would apply to ArduPlane and ArduRover too, in addition to ArduCopter. So I'll be using this Copter 4.05 official version, but this would really apply to ESCs on a rover or an airplane too. So I'm using Mission Planner current version 1.3.74. You'll notice that right now there isn't a mandatory hardware option in this list. That doesn't come up until you connect with the PixHawk. So I'm going to click Connect over here. All of this escape calibration is dependent on what the ESC needs. Some ESCs nowadays don't need calibration. The ESC manufacturer will have the sequence in that documentation for what the ESC needs for calibration. I probably would do that just a couple of times with just the ESC and receiver and transmitter till I could get familiar with that ESC's calibration procedure. Let's say that the ESC calibration procedure says turn on your transmitter, turn on your receiver, have your receiver hooked to your ESC, and put your throttle position at high and power up your ESC. Your ESC will beep X number of times to say it's in ESC calibration mode, and then it'll give you 3 beeps to say it's sensed high throttle. At that time you need to lower the throttle to 0, and it'll give you 5 beeps, and then it'll reset and go into normal mode, and your calibration is complete. If you can do that with the transmitter, receiver, and ESC and become familiar and comfortable with that procedure, it will help a lot. Because this really is all dependent on how the ESC wants to be calibrated, and if the ESC is a new one and doesn't want to be calibrated, you don't even really have to do this step. But let's say you do then want to do it with the PixHawk in the circuit, so you would take the connector loose from the ESC, put your RC into the PixHawk, take your throttle servo out of the PixHawk into the ESC, and then we would do this. Underneath mandatory hardware, you would use the ESC calibration function right here. That has to be after radio calibration. Minimum radio calibration has to be done so the PixHawk will send the signals through itself. So ESC calibration here is what we'll be talking about real quick. Don't want to confuse you a lot, but I am going to hit flight modes right here, and you can see that ArduCopter defaults to stabilized mode. There is no manual mode. You won't find a manual mode in this list. There is not one. That's just for ArduRover and ArduPlane, the manual mode. So that might have been my confusion last night. So we'll come in here to ESC calibration, and it tells you what to do right here in the top. I don't think this bottom is needed, but this list is somewhat incomplete because it doesn't really include what your ESC is wanting to see out of all of this, because that varies from ESC to ESC, and ArduPilot, Mission Planner, ArduCopter doesn't know what ESC you're using. So this is kind of a generic checklist. So right here we would put remove props, okay, safety thing. After pushing this button, click right here, disconnect the USB and battery power. What's not in this list is at that time you should make sure your transmitter is set up the way the ESC documentation says it needs to be to calibrate your ESC. More than likely that's throttle all the way up. So you'd want to put your throttle all the way up right here between these two steps, and then plug the battery back in. At that time, the LEDs will flash on the PixHawk. It'll make all sorts of sounds if you've got a piezo buzzer hooked to it. And it warns you here that you also have to push the safety button so that the Pixhawk arms to pass that signal through it to the ESC. Now all this has to take place in the time period that the ESC is looking for the command to go into calibration mode. So if this right here between plugging the battery and getting that safety switch pushed takes too long, the ESC could fall out of or quit its calibration mode and just go into normal mode. After that, the ESCs will beep as they are calibrated. That's basically according to the procedure that the ESC does. If it says it's going to beep 4 times at high throttle, and then after you hear that, you want to go to low throttle, and it's going to beep 6 times long and 3 short beeps. That's what's going to happen during this step, and it is calibrated. You just restart everything. Restart flight controller normally here is just all you would do. Now there is this one function that bites people frequently on this step. You have to come over here in configuration, and I use the full parameters list, and I'm looking for arming check. I can either go down through this till I find arming check as a parameter, or if I'm at the top, I can type into the search box over here just ARM. Don't have to hit enter after it. It'll go find the first occurrence of that and finds arming check here. And you can see by default when ArduCopter is loaded into a Pixhawk, the arming check is set for all. The barometer has to come up and say it's ready, the compass, the GPS, the inertial navigation sensors, the accelerometers and gyros have to come up to speed and say they're ready. Does a perimeter check on all the perimeters. For perimeters that are just out of bounds. Battery level check. Here's your hardware safety switch that needs to be pushed to allow it to arm. There's what gets most people in trouble. Even if this was just set for arm hardware safety switch only, the Pixhawk wouldn't be sending out a high throttle signal to the ESC for calibration until this hardware safety switch is pushed. That's what they're talking about over in this other little list in this right here. Push safety switch if present. Well, you can also just set it here for calibration. I would remember that the default here is all. I would just set it for none. I would come in here, hit 0, tab, right parameters. I would probably then cycle this software, cycle that, so that the arming check isn't even needed. This gets people in trouble on this ESC calibration right and left, because the Pixhawk waits around trying to make sure all of these are, here they are, the barometer, the compass, the GPS, the inertial navigation systems, perimeter checks, that your SSI or RC channels are good, your board voltage is good, your battery level is good, logging, hardware safety switch, GPS configured, system, mission, rangefinder, all sorts of check. If this thing is like this, then you're probably going to have a hard time. If this is set to the default one, you're going to have a hard time getting that calibration done over there. So basically you can also come in here and just say turn all of these off, which makes this a 0 out here. Makes this a 0 out here. Tab and right. Try that and see if that works. Let me know again.